Quick announcement. I'm Amir. I help run Bernardo Kastrup's weekly Q&A with realityinmind.com. And next week, the 29th of July, we're joined by Christoph Koch, who, as you may know, is a celebrated neuroscientist famous for instigating the modern search for the neural correlates of consciousness, together with Francis Crick, who in turn is famous for being a Nobel Prize winner, in fact, for being a co-discoverer of the structure of DNA. If you'd like to join that meeting live, you can find us at withrealityinmind.com. You can also join weekly Q&As with Bernardo Kastrup, and the following video is an excerpt from yesterday's Q&A in which we prepared for next week when we're joined by Christoph Koch, the 29th of July. We got Bernardo to give an introduction to IIT and also to explain the potential implications of the theory to idealism. Okay, so we've got two sessions on IIT. The way I'm thinking about it is we've got a wide range of people and exposure and understanding. So this week will be a little bit more for the, let's say, beginner questions or people newer to it or wanting to understand why, as an idealist or someone open to idealism, you might care. And then it makes sense to have the more challenging, speculative, harder questions, more advanced questions, we could say, for next week when Christoph Koch is here. So we really take advantage of him being here. Hopefully that makes sense to you as well, Bernardo.
Yeah.
And hopefully that way, many more of us will be able to follow the conversation next week, including me. I consider myself a beginner to understanding this. I don't know if you had a chance to scan. I wrote my best attempt at an overview. Um, it-
No, no,
I
but
understand you're normally too busy to do that.
hopefully I'm fluent enough in it that I can talk about it without pre-read. Hopefully, let's see how it goes.
Yeah, the thing we've had at least, I would say with Christoph and with you, we probably had 8 hours of conversation on it, and I've read various things and watched various videos, and the penny only just dropped for me. I don't know why it took so long. Um, that one thing that is unique, if I've understood it, about IIT is that it starts with consciousness and it looks at like, well, there's certain things that we can be certain attributes that we can be certain consciousness has, because I can observe them directly. They're almost self-evident. And a couple of examples are this experience I'm having right now is specific. It's different from the one I had 5 minutes ago. It's different from the one I'll have in 5 minutes. Looking at a red apple is not the same as looking at a green apple. So it's specific. That's a characteristic of experience. Um, Another example is that it's unified. It feels like there's one consciousness here, and it's structured. There's an up, there's a down, there's distance. It's not just a random mishmash of phenomena. And so this is the just wanted to confirm this with you, Bernardo. What just dropped for me very recently was, okay, I'm starting with that. And then if I'm looking at physical systems and trying to figure out which physical systems, including the brain, looking at as if a physical system, what qualities would I expect a physical system to have if it was the substrate for, or in analytic idealism terms, was representing a conscious experience? Well, I might expect it to have some specificity, some structure, to be integrated and unified in some way. I thought I'd put it in my words because they may be more simple than Christoph's words or yours, but am I close to getting? Okay.
There are, and if I would be uptight and retentive about specific use of words, I would have used a couple of different words. But yes, I think your intuition is the right one. Yes.
Yeah, and feel free to say which word,
Okay.
because that will help us understand it even deeper. If you want to say, oh, that word isn't as good as this word, it'll help me as well. So,
Yeah. IIT is more or less unique in science, in neuroscience, in the sense that it bites the bullet. It starts from how experience feels to us. Because amazingly enough, in neuroscience, people go off trying to explain experience without first characterizing that which they are trying to explain. Experience is like something and not like something else. So it's useful to first characterize what it is that you're trying to account for. So you're more guided in trying to account for that. That should be obvious. We do it for everything in science, except for consciousness. In most theories, IIT is the exception in that regard. They first characterize what it is that they are trying to account for, right? So they characterize experience. And that gives us the 5 basic axioms of IIT. The first one is experience has intrinsic existence. In other words, experience exists for the experiencer. In other words, experience exists for itself. It doesn't require outside observation to be said to exist. I could be a Boltzmann brain alone in a universe that is a complete vacuum, and my experience would still exist because it would exist to me. Experience exists to itself, regardless of whether something else or somebody else is observing it from the outside. And this axiom in practice unfolds into something that is less explicitly stated, but is fairly intrinsic to IIT, which is experience is fundamental. Something that exists for itself is in principle fundamental. Not necessarily logically speaking, but usually translates into that as you operate with IIT. What you're trying to do is you're trying to account for the qualities of experience. You're not trying to account for the emergence of experience out of something supposed to be non-experiential. So you don't try to explain how experience pops out of something that is not experience. You don't try to do that in IIT. You simply characterize the experience as given, and you try to infer the qualities of experience from the characteristics of the substrate, for instance, the brain. So that's the first axiom. Experience is intrinsic and usually translates into experience is fundamental.
The one thing, because I'm going to assume where I was stuck is where other people have been stuck. One word that confused me a lot, which is why I think it took me so long to get this, is the use of the word substrate, which seemed to imply to me it's the cause, it's what holds it up. But you're saying IoT is metaphysically agnostic. It's a placeholder word, but it's not necessarily claiming the brain is the substrate, the thing that creates consciousness.
IIT starts as metaphysically agnostic, but if you deeply study it, it does have some metaphysical implications. So it's not the starting point, but it ends up being an implication. And those implications are not physicalist. They are more on the side of idealism than anything else. So when they use the word substrate, they don't mean the cause. I agree with you, the word is not ideal because it seems to imply a ordering, as if the substrate needed to exist first and then experience. And there is nothing in IIT that would require that. The substrate is a correlate of experience. Under the terms of analytic idealism, experience exists for itself, so just like with IIT, and the substrate is the dashboard representation of experience. In other words, in addition to existing for itself, experience looks like something from the perspective of others. The substrate is what experience looks like from the perspective of others. So your brain is what your inner experience looks like to me. Under IIT, the brain is just the substrate. So because to explain what I did now is already to make a metaphysical commitment, which they shouldn't, right? Any metaphysical commitment from IIT should be an implication of the theory, not an input to the theory. And so they do it nicely. So yes, I also don't like the word substrate, but all it means is that experience exists for itself, but from the point of view of others, it also appears as the substrate. The substrate is a correlate of experience, a correlate that you can objectively measure without experiencing those experiences yourself. That's basically what the substrate is. So one of the axioms we already talked about, experience is intrinsic. The other one is composition. Composition means that experience is composed of a number of qualia states. For instance, if you're looking at this bottle, there is the neck of the bottle, that's a qualia state. There is the shape of the body, it's a qualia state. The color black is a qualia state. The color silver is another qualia state. The little shield from the University of Heidelberg is another qualia state. It's specific forms. So one holistic experience, for instance, my experience of being me right now, is composed of identifiable distinct qualia states, forms, colors, notes, in the case of melodies, textures, and so on. And they all come together holistically to form this experience. So that's the axiom of composition. Why is it an axiom? Because we are just characterizing experience. We're not theorizing about it. We are just describing what it is. And then we will create a theory to try to account for it. But at the level of axioms, we are just describing what experience is. It is intrinsic. It exists for itself. Two, it is compositional. It's made of identifiable states. Experience is specific. Looking at this bottle is different from looking at this phone. These are different specific experiences. Any one experience is what it is and not something else. That's specificity. It correlates with information. Experience can be described with a specific informational landscape. The other one is integration. That's number 4, integration. I don't experience the Heidelberg University shield, the color black, and the silver neck as separate things. They are qualia states in this unified whole that is my experience of being myself. So there's this integration. The information that describes an experience is integrated into a whole that you cannot tear apart. I cannot tear apart the experience of silver color here and black color here while I'm looking at it. They are integrated into my experiential landscape. Yeah. So that's the fourth description, the fourth axiom, integration. And the final one is exclusion. Your experience is separate from mine. That's basically the axiom of exclusion. I cannot simultaneously have two different experiences, right? Whatever I am experiencing now forms a whole, but what is not in that whole, I'm not experiencing. That's exclusion. And that's one of the key axioms in IIT for analytic idealism, because it is the thing that IIT then accounts for that allows us to explain dissociation. It's this principle of exclusion. You could even call it's the principle of dissociation. And the way it's folded into the theory gives us an account of dissociation. It's not a complete account. I think I can even say that even Giulio agrees with me that it's not a complete account. There's still work to be done. And it's been done. We got funding last year. It's been done. But it gives us a fantastic starting point because it's a coherent starting point that fits very well within the mathematical instrumentation of IIT. So it's the most promising thing out there to account for dissociation. So IIT starts from these 5 principles that I just discussed with you. Experience is intrinsic. It's compositional. Let me read my little list here so I don't...
Specific.
Intrinsic, compositional. It's specific. It's unitary or holistic, and it's definite. In other words, the principle of exclusion. Starting from this, which is a characterization of a given. Experience is given to us. So we are just characterizing it. Starting from these 5 principles, IIT then provides a mathematical framework that allows us to infer experience, the qualities of experience, what someone is experiencing, if we only have the substrate, if we only have brain activity, if we only have brain anatomy. By looking at that alone, based on the 5 axioms, we can infer what the owner of that brain activity is experiencing. Now, this is critical in medicine. You want to know if somebody apparently in a vegetative state is actually fully conscious and just cannot move anything, cannot say anything. That's locked-in syndrome. And that's the first key application of IIT. But under analytic idealism, IIT goes well beyond operational applications, because under analytic idealism, the substrate is the appearance, is the dashboard representation of experience. It doesn't have autonomous or fundamental existence. It's just what something looks like from the outside. What really exists is experience. But of course, we are trapped in our own dashboard. We have direct access only to our own experience, and everything else is representation from our point of view. Even your mind to me is a representation. I only see your body, which is what your mind looks like to me. And the rest of the physical world is also a representation. So beyond my own inner life, all I have is the substrate, right? So it's very useful to have a theory that allows me to infer the real thing, the noumenon of the world, what the world really is, even though I only have the substrate, even though I only have the dashboard representation. So IIT, under the perspective of analytic idealism, brings us from mere phenomena, mere appearances, into the thing in itself. We can make a guess now about what the thing in itself is, what the world actually is, in and of itself, beyond the mere dashboard representation. So now it's a spectacularly important theory at the level of foundations of physics, neuroscience of consciousness, but also metaphysics. And it's not only for clinical applications.
So I'll just say this back to see if I've understood. If I know that I'm having a certain experience and and my brain is in a certain state, I'm having experience X, let's say being in love, and my brain, and it correlates with a certain state in my brain that can be identified or measured by integrated information theory. I can make an assumption if I look at your brain and it's in the same state that you might also be experiencing the same state of feeling
Correct.
in love.
Correct. So the way this starts is from the 5 axioms. So experience is specific. There is the exclusion principle. Experience is what it is and not something else it could be, or something else that is being experienced elsewhere. The specificity of experience is the informational aspect of it. Experience can be characterized by a set of qualia states that corresponds to an informational landscape, right? So these are the characterizations of experience. Now, when it comes to the substrate, what we are looking for are patterns in the substrate that correspond to these 5 axioms. So we are looking for information in a substrate. We know that experience is unitary, so that's the integration principle. So we are looking for information integration in the substrate. We are looking for measurable physical characteristics in a substrate that correlate well with these 5 axioms of experience as described from a first-person perspective. So if you're looking, for instance, at a part of the brain where there is very little information integration, for instance, the cerebellum, which is at the base of your brain here at the back. Most of your neurons are in it, even though the cerebellum itself is small. Most of your neurons are in there, but it's not associated with consciousness. You can extirpate your cerebellum. You'll not be able to move, but you will still think and feel, and everything will still be there. Why is that? If you look at the anatomy of the cerebellum at the cellular level, it doesn't integrate anything. You have these cells that propagate forward, and they don't form reentrant loops. So there is no integration. So that cannot be the substrate of this holistic integrated experience I'm having right now. The substrate doesn't betray analogous characteristics, right? So that's one of the things you can do. Exclusion is another thing. You're looking for a substrate that has, to speak mathematical language, that has some form of Markov blanket. You don't need to know what it is. It just means that the physical substrate is bounded. It's not sort of spreading around into the world at large. There is an identifiable boundary to it. In our case, it's the brain and the dura mater around the brain for egoic experiences. So given these 5 axioms, you already know in principle what physical characteristics to look for in the substrate that could support experience characterizable according to these 5 axioms, right? You know that in principle, you know what to look for. What you have to do now is make it more rigorous. You have to mathematize it. You have now to quantify the amount of information that I integrate in my normal experience from a first person perspective, and the amount of information that is integrated in the substrate if I look at the topology or no, the physical characteristics of the substrate. And you can use information theory to quantify exactly that. You can quantify the individual qualia states that holistically come together into this unitary experience thanks to information integration. You can even quantify exclusion. You can predict when, by integrating more information, you will create an exclusion boundary, because by excluding something, you may actually integrate more information. The information is less diluted if you exclude certain things. In IIT, this is called the formation of fault lines. It's what it's technically called in IIT. So that's what IIT does. It starts from step 1, characterize experience. That's a given. Let's just characterize what we are working with. Let's understand what it is. Step 2, given this characterization, what are the guidelines for what to look for in a substrate that can sustain experience or correlate with experience in some way? We can do that qualitatively. That's step 2. Step 3, let's quantify that through information theory. And that's how you get the integrated information theory part. Once you've done step 3, step 4 is you calibrate. Now you will look only at the substrate, quantify everything, and then you will know how much information should be in an experience that is correlated with that substrate, the general characteristics or qualia states of that experience. You extract that from your theory. And now you ask a subject who owns that substrate, a living human being. You ask that subject, what are you experiencing right now? And that feedback will allow you to calibrate your model, your IIT model that's based only on the substrate. So by iterating between a model based on the substrate and what subjects are telling you, the subjects who own those substrates, those brains, you can calibrate your model. And once you've done this 4th step, this calibration, now you have the 2 sides, the substrate and experience as directly perceived. Now you have a theory that allows you to bridge one to the other. So if you have only one side, you can infer the other. Whatever side it is, after calibration, you can infer the other. And that's what makes it powerful. It's when you don't have one of the sides. That's very important. So for instance, if in the future we get better at associating psychological pathology with brain function, we are very bad at that right now. We cannot find proper correlates between, for instance, autism and particular patterns of brain activity. A lot of stuff is not grounded in neuroscience. A lot of stuff in psychology is not grounded in neuroscience. But suppose we get better at that, and IIT is, I think, the best hope we have. You will be able to, from a clinical interview with a subject, you'll be able to infer what is going on in the organic substrate. You may be able to, you may be in a position that you can make a physiological or anatomical diagnostic based on subjective reports. Right now, we can't do that, but IIT is an avenue to try to do that. Or the other way around. You have somebody who is sufficiently impaired that the person cannot report with any degree of depth. Some people are naturally like that. Narcissists are very bad at reporting their inner state. They're exquisitely bad. They have what psychologists call a false self because they are unable to introspect with enough depth to understand who they are. You may want to rely on your actual physical measurements of patterns of brain activity to make a diagnosis or to devise a treatment plan or whatever. So these are the clinical applications of IIT. When you, instead of having both sides experience and the substrate, you have only one and you can infer the other. Philosophically, it goes much beyond, because all we have is the substrate of the physical universe. That's what the physical universe is. It's a substrate. Imagine if we could, with high reliability, infer what it is like to be mind at large. That would be groundbreaking philosophically.
It's it's like the Rosetta Stone, this fourth step of reading the world, reading physical
Correct.
symbols.
Yeah, the calibration step is like the Rosetta Stone. You create a model based on first principles or the axioms. You instrument it mathematically with information theory, and now you go calibrate it. That's the Rosetta Stone. So the Rosetta Stone is when you have an instrumented subject, somebody with an EEG cap or inside an fMRI, who is having an experiential stimulus, describes it, while his brain activity is being measured. So now you have the substrate and you have the subjective experience. So you can calibrate the model that links the two together. And after that calibration, you can lose one. If you have the other, you can infer.
Mhm. Amazing. Um, so Sarah Victoria Barton, are you here?
Yes, I am. Yeah.
You had a
Hello.
question on measurement.
Yeah,
I
it's
think that would make sense at this point.
yeah, it's a very basic question which I feel a
To,
bit not
today is four basic questions.
okay.
So,
So so I'm not a scientist or a mathematician. Um so I would really appreciate a kind of the way I've put it in my question is an idiot's guide to how phi is calculated. Um What I do understand is that phi is a measurement of the level of the integration of an entity, but how is that actually measured? Um, and if you take a mouse, for example, how would you go about measuring the integration of that mouse, and what information about that mouse would contribute to the calculation or the measurement?
Any brain state contributes to calculating phi, the amount of information that is integrated. The anatomy where those brain states occur is also very important to calculate phi because it gives you an idea of the counterfactuals. In other words, the mouse has this brain state, but it could have had that other one. The counterfactuals are intrinsic to the calculation of, okay, I have, let me take a few steps back. Now I'm getting ahead of myself. The birth of information theory was in 1948. And a two-part paper published in 1948, and it defined information rigorously. And information is defined as a level of surprise. What does that mean? For instance, if you call somebody, no, suppose you want to know whether somebody is married or not. When you hear the answer, I am married, there is very little information there because the only other possibility, the counterfactual, was I am not married. So when you hear the answer, you're adding very little information because you knew it could be only one of two answers. So now you know what the answer is. You exclude the other. You excluded 50%. So only that answer doesn't tell you much. But suppose your question is, what is the cloud cover over my city right now? And then you get a photo of the cloud cover of your city. Well, that photo has a huge amount of information because the cloud cover could have been gazillions of other things. The clouds could be distributed in a totally different way, have different shapes and forms, densities. So by looking at that one photo, you have excluded gazillions of other possible photos that you would have gotten as an answer to the question, what is the cloud pattern over my city right now? So this is what information is. It is when you learn what the state is, how many other states it's telling you that it is not. So in the case of are you married or not, the answer only excludes one other state, very little information. When the question is give me the cloud cover over my city and I get that photo, it's excluding countless other possible states, what the cloud cover could have been over your city. So that photo has a lot more information than the yes or no of the first question. So that's how information is defined. It's defined in terms of the counterfactuals. In other words, what you need to know is what is the state, what something is, what is the pattern of brain activity in that mouse's brain right now. And you need to know what other patterns of brain activity that brain could have supported. The more it could have been, the higher the information is in what it actually is, in its present measurable state. So to calculate phi, we need first the anatomy, because that gives us the counterfactuals. What are the possible distribution of qualia states given the substrate? The more integrated the substrate is, like here, the posterior hot zone here in your brain, these neurons are very highly interconnected and they form all kinds of reentrant loops. So when you measure the pattern of brain activity in that part of the brain, the counterfactual is enormous. It could have been gazillions of other things. So there's a lot of integrated information. But when you measure the states in your cerebellum, there is very little information because there are no reentrant loops. The interconnects are very loose. Everything just flows down. So there's very little information. And lo and behold, you can remove your cerebellum and you will not notice its absence until you try to move. You're not going to move. So these are the two things we need to calculate phi. Phi is the Greek letter. It represents the amount of information integrated in a global experiential state. In other words, the amount of information that you're experiencing right now, that's given by phi. I can describe that subjectively, like I'm experiencing a very rich Picasso paint, that's a high phi. But you can also infer that from the outside without access to my experience by doing two things: understanding the anatomy of my brain, so you know the counterfactuals, what are the reachable states, and measuring what the actual brain activity is. So you know what state it is. And now you know the information. Now that information, because of the fourth axiom, integration, experience is holistic, right? I don't experience this bottle separate from this phone. The phone and the bottle are both in my unified experiential state. They are both part of what it is like to be me right now, right? So you need to have a lot of information, and I just described to you how you do that, but that information needs to be integrated. In other words, there have to be reentrant loops. Things have to be sort of coalescing together in an interconnected web for that information to be integrated. Otherwise, you have lots of states, but they are all flowing downwards. They are not interacting with each other. They are not interconnected. So you may have information, but it's not integrated. And we know, because of the 5 axioms, that we experienced integrated information. We don't experience fragmented information. I'm going to make a disclaimer about it later on after I finish answering your question, but I don't want to confuse you right now. So that's what we need to do to calculate phi. We need to understand the anatomy, because that gives us the counterfactuals and that gives us the possibilities for integration. Then we need to measure the actual states on that anatomy. And we need to see the dynamics of those states. Which states are influencing what other states? These states correspond to the second axiom, the composition axiom. One holistic experience is composed of identifiable qualia states. Like, this is a set of qualia states, this is another set of qualia states. They're both integrated in the holistic experience of Bernardo being himself right now, but they are still identifiable states, holistically integrated, but identifiable as segments. So to understand how these identifiable segments, how tightly they are integrated, we have to look at their causal effect on other states. When one state causally influences another, you have more integration. This is very intuitive. For instance, if I smell a birthday cake, I think of party balloons. That's one set of qualia states causally influencing another set of qualia states. One may be perceptual, the other may be memory-based, right? My memory of party balloons. So to see phi, we also need to see how these states are causally influencing one another in an interconnected whole. Now, this is all the theory. And you can mathematize all this through information theory. You can actually have very rigorous ways of calculating phi. What is the limitation? The limitation is practical, because to calculate phi precisely, you need to have infinite accuracy and resolution in your measurements of both the anatomy and the states. And that is impossible, because even if you can measure the activation of a single neuron, that neuron has trillions of internal states. So how far do you go? You have to start measuring quantum events now, and this is now empirically corroborated. It turns out that within microtubules, microscopic structures in the cytoplasm of our neurons, you can have quantum coherence over large distances, even millimeters. So to calculate phi in that case needs you to go down to the quantum level. Of course, we are centuries away from this, if it is at all possible. What we can do, and that's what the whole of science does. The whole of science does exactly this. What we can do is make simplifying assumptions and ignore all the fine-grained information and focus on what you can measure and make some inferences, some guesses based on what you can measure. So, fMRI is temporally more or less precise, but spatially it's iffy. But if you do MEG, you put your head inside an MEG and you measure that. Which one is an fMRI is spatially accurate but temporally inaccurate. An MEG is temporally accurate but spatially coarse. So if you start measuring everything in every way you can, you will have some resolution in space and some accuracy in time. You can already calculate sort of a coarse phi. And this is already incredibly useful for the following reason. Suppose somebody is in a coma and you want to know how to go about that patient. If the patient is vegetative, you don't need to have any psychological support, any enrichment activity, any attempt to communicate, because it's a truly vegetative patient. But if the patient is in locked-in syndrome, the protocol is very different. Now, family members know that the patient is actually hearing what you're saying, is understanding it, probably is bored out of his wits. So it's a different protocol to deal with that. You need to know that. How precisely do you need to calculate your phi for that? Well, very coarsely. You only need to know, is this person still conscious? Or is he truly vegetative? A very low residual level of consciousness that doesn't require you to talk to that person or follow any protocol of this kind. You don't need an accurate calculation of phi. You don't need to know exactly the details of what that patient is experiencing. Every detail of the patient's fantasies and dreams and thoughts and emotions. You don't need that. You only need to know, is the patient still there? Is there still a conscious ego there? Or did that dissolve into mind at large already? That's all you need to know. You do not need quantum level measurements to have that answer. You need to make some measurements of phi, even some active measurements of phi. And this is a critical thing. Everything I've described so far are passive measurements. Like you put somebody under an fMRI scanner or an MEG or an EEG. You are not putting an electrical impulse into that person's brain and checking how the brain reacts to that impulse. So it's a passive measurement. If you do insert an electrode or a number of electrodes into the patient's brain and you pulse them and you insert a stimulus directly into the brain and you measure how the brain responds and you calculate the information integrated in that response, it's much more powerful than a passive measurement. And that's what Marcello, Giulio, Christoph, that's what they are trying to develop right now. It's an instrument that does precisely that. That can give you, even at low resolutions of measurement, because you're measuring stimulus response and you know what the stimulus is, you can already, with high reliability, say this person is vegetative, or no, this person is locked in. So the entire protocol is different. So this is the conclusion of what I'm trying to tell you. It is very difficult to calculate phi precisely. We cannot have all the fine spatial details and temporal details of both anatomy and function. But we don't need that either for every practical application. And probably we don't need that for every salient philosophical application. I don't need to know exactly the precise characteristics of the mental complex in mind at large that corresponds to the sun. But I would like to roughly understand, is that an outpouring of love, of anger, or something totally different? And that IIT could probably get us closer to.
Thank you so much, Bernardo. That is really helpful, even for somebody who doesn't have any scientific or mathematical kind of understanding beyond the very, very basic. So thank you. I'm really intrigued to know more about how IIT could help us understand something like the sun, but perhaps that's a question for another time.
Yeah, the IIT guys are not trying to do that right now. And you see, even though they have been extraordinarily conservative and rigorous, they still get that disgraceful letter written about them. Imagine if they would be talking about what it is like to be the sun, or to be mind at large with suns in it. This is our culture has to evolve quite a bit in the direction of reason before that can be done.
Or you get a banned TED Talk like Rupert Sheldrake and become
exactly
much more famous.
There you go.
The ideas become much more widely disseminated on account of being banned.
Look, Giulio is extraordinarily careful with words. He weighs and thinks about every word. He does not say any word that is not precisely the word that he should be using. And even then he gets shit thrown in his direction. Imagine if he would become a philosopher like me.
Al, can you tell me if your question has now been answered? Maybe just unmute if it hasn't. The round wanting an example of it in action. I think that's been answered, but if you don't feel so now.
I don't know if I would. I don't know if I would be asking the question now, as I did earlier. Now that I've heard Bernardo's explanation, I was looking for something kind of visual. Is there a way to illustrate a simple problem where where this model applies, and is there a way to show IIT in action?
Yeah, the way to visualize what IIT predicts to be the substrate of rich experience, in other words, high integrated information, is to look for things that are very highly interconnected and have these reentrant loops. And loops are formed because of all this connectivity. So you want things that are very highly interconnected and form a lot of reentrant loops and have activity distributed across this network of reentrant loops. In other words, things that look like brains, especially the posterior hot zone here. If you look at it under the microscope, it's a lot of interconnection in every direction. Lots of reentrant loops being formed. That's what you're looking for. So, for instance, I'll say that it's risky what I'm about to say. If you ignore the states and you only look at the anatomy to calculate phi, remember I told you that to calculate phi, you need the anatomy, but you also need the causal relations across the states that are hosted in that anatomy. So let's forget the states for now and look only at the anatomy. The anatomy of our universe at its largest scales is extremely appropriate for information integration. You have very high networks, webs of interconnects. That's why it's called the cosmic web. Lots of reentrant loops. I don't know whether you have seen pictures of our calculations of what the universe looks like at its highest scales. It is exactly that you're looking for. Now, we cannot say that therefore the universe is one giant ego because of the causal part. The distances in the universe are humongous, and they are increasing because the universe is expanding. That's dark energy, the effect of dark energy. So, and because of the speed of light limit, although you have this web, this anatomical web, states in different points of this web don't causally interact much with other states because they are not fast enough to send a stimulus given the enormous and growing distances in order to integrate information. The universe is too young to have allowed for integrated information at those scales. At least that's the conclusion we have to derive from current cosmological models, the current standard model of cosmology. The disclaimer is that the James Webb Telescope has now shown that our standard model is wrong. We have to rethink the whole thing. So who knows? Who knows what the conclusion will be 5 years from now? But right now, we should err on the side of caution and say, even though the universe is ideally for information integration from an anatomical point of view, from a functional point of view, the point of view of causal powers, how do those states causally influence one another? It doesn't integrate much information. So until second notice, that's the conclusion. But your question was, what should we look for? Well, we should look for things that are similar to the cosmic web of galaxies or mammalian brains. That's what we should look for. I'll tell you what does not fit the bill. Large language models do not fit the bill. They do not have high interconnection. The direction of data flow it only goes forward from one side to the other. So in inference, it goes, say, down, and in training, it goes up during backpropagation. But it doesn't have loads of reentrant loops, very little integrated information in LLMs. So there is no reason to think of an LLM as a particular identifiable complex in mind at large. It fails the principle of integration, both anatomically and functionally. So yeah, that would be my answer.
Just to, you can follow up in a second, Al. You're muted, but I just want to check, Bernardo. Is this the image you meant, just to illustrate it for people, or maybe this one? Either of those?
This one, not the other one.
This one.
Yeah. If you do, what's curious about this, and Franco Varta and Alberto Faletti have written about it extensively. One is a neuroscientist, the other one is a cosmologist, an astrophysicist. They calculated the frequencies of matter and energy distribution at the universe at the largest scales. Technically, they did a spatial Fourier transform of the universe at its largest scales, which gives you, the frequencies under which matter tends to be distributed across space in the universe. And then they did the same thing for a mammalian brain, and the two results are surprisingly aligned. They are exquisitely aligned. From a quantitative point of view, the cosmic web of galaxies, from a network topology point of view, quantitatively, it looks unreasonably like a brain. And then there is no known physical reason why that should be the case at all. We know that it is like that because of the distribution of dark matter. Even though we don't know what it is, we know where it is. So we know how it formed, but why it ends up having quantifiably largely the same network topology as mammalian brains, we don't know. Of course, you guys know. You're analytic idealists. You know.